Good morning all. Welcome to the session of Dbms your models. Before starting the today's session guys, we'll try to recall the things of previous session. In the previous session, we discussed about how to convert a given ER model into a relational schema, right? So a conceptual schema that we have seen. There we have discussed about 7-step ER to relational mapping algorithm. So we'll try to recall that 7-step algorithm. What are the 7 steps we have used, especially in converting a given ER model into a relational model, right? Relational database. So guys, there we have seen as the first step as mapping of regular entity types. What exactly we made is, we are almost in the 7 step, all 7 steps discuss about how to map each and every notation as what we have used in any ER diagram into a relational, what is its equivalent representation in relational model that we have seen, right? So guys, those 7 steps comes like this. The first one is mapping of, step 1 is mapping of regular entity types. Regular means strong entity types. What is the solution we discussed? Go with creating a new relation and have all attributes including the composite attributes. Then there we discussed one interesting thing, how to represent a composite attribute. How guys? Yes, composite attributes, it's simple components. What are the because composite attribute is one where it compromises of plenty of simple attributes, right? Simple components. So represent each simple component as a separate attribute in the newly created relation. This is what a solution we have discussed, and as usual underline the key attribute as what you have identified in a strong or a regular entity type, right? So then after we move to how to represent a weak entity type, right? So always, even for a weak entity type, we are going with creating a new relation, but one thing we discussed, always a weak entity type entities, right? That means the tuples are identified based on what? The strong entity type, that means a owner entity type key attribute. Make use of that owner entity type key attribute as a foreign key in the newly created relation for a weak entity type, right? So this is what we did. Next, after that, mapping of one-to-one relationship type. Always when we map a one-to-one relationship type, then during the time we are going with what? A foreign key approach. That means don't go for creating a new relation. Instead of that, for one-to-one and one-to-many, for both of them, one-to-one, one-to-many are it's opposite. That is what many-to-one. Even for that, for all these 3 cases, we are not going for creating a new relation. Instead of, we are making use of a foreign key approach. What exactly a foreign key approach is? The foreign key approach tells us make use of a primary key attribute from a participating entity type as a foreign key in another relation. That means where we have created, that means where we are having a total participation, right? To that end, in the table you make it as a foreign key, right? Where we are having a maximum participation, to that end you apply, you take its opposite, that means a participating entity type key attribute as a foreign key, right? So this is what the beauty we have discussed. Then for many-to-many, for most of the cases, for many-to-many cardinality, if you want to show, it requires always a new relation, right? So without that, because most of the time that many-to-many requires that the primary key values of 2 participating entity types to be repeated as many times as we want. That cannot be achieved with the help of foreign key approach, right? So one we can achieve, but by making another attribute as a foreign key, but so one key attribute that we cannot repeat, right? So this is what a problem we discussed with respect to foreign key approach. Instead of that, what best we can do is go with creating a new relation. There make use of the 2 participating entity type key attribute as foreign keys, and if any attribute, if it is attached to that many-to-many cardinality relationship type, right? So there even make use of those attributes in the newly created relation, right? So this is what we have discussed, so that we can repeat as many times as we want both foreign key values, right? Possible. Next, we move to how to represent a multi-valued attribute. It's a one more kind of an attribute, right? So there is no problem with respect to simple single valued stored and as well as the composite attribute, because in all the cases we are recording all its simple components. but this multi-valued attribute takes more than one values for an entity, right? So then how to represent it? It requires one more relation to be created, right, that we have seen, because an entity, I want to write multiple values. So for that, since we made in that entity that attribute as a key attribute, one of the attribute as a key attribute, that I cannot repeat, right, because that primary key doesn't allow, right, that violates the key constraint, right. So for that, what is the best thing we can do is go with creating a new relation, and there you make that key attribute as a foreign key in that newly created relation along with this multi-valued attribute, right. So this is what we have seen. Then after that, as a last step, we discussed about mapping of NRI relationship type. What is that? NRI represents the number of entity types which are participating, especially in case of NRI. When we call it as NRI relationship type, suppose if any relationship type, in any relationship type, if more than two entity types are participating, associated, then such relationship types, we call it by name NRI relationship type, where n takes a value which is greater than 2, right. So this is what we have seen. Then we took one small example with respect to project, part, supplier, those things. There we have seen more than two entity types are associated, participating in that relationship type like supply, right. So there always, even for an NRI relationship type, we are having a many-to-many cardinality most of the time, either to any one of the end. So during that time, go with creating a new relation and make use of all primary keys as foreign keys in a newly created relation along with the attributes which are directly connected to that relationship type, right, that NRI relationship type. This is what we have seen. So this is all about the highlights of 7-step ER to relation mapping algorithm. Now guys, I am with one more interesting ER diagram. Almost we constructed this ER diagram by reading out the requirement scenario, right. So the requirement. Now guys, we'll try to convert this ER design into a relational model, guys. So before starting this new scenario, what I'll do is I'll try to recall that means the story. I'll try to make you to remember the story behind this ER diagram. Actually, this is a story. It's an exercise 2 of our lab set. Actually, the story behind this ER diagram is it's all about a cricket tournament, like as what we are having an IPL kind, right. So what exactly there in an IPL? There are plenty of teams which are contesting, right, and there are so many players, there are plenty of players, right, and each player is associated with any one of the team, always, sure, right. Then after that, a team contains many players, right, that also sure. Then after that, we have seen that the matches will be played between the teams that we have shown here by creating a separate entity type, where each match is identified based on a match ID, right, and each match is played in a scheduled date and a time. It is pre-scheduled, right, that all we have recorded, that all we want to record in a database. Then after that, one thing is sure, always cricket is a game. It is always played between the two teams, right, and always at the end only one team is going to win, you know. So that also we want to record, since we think so very much sure. So for that, even that also we have recorded. Suppose if we don't, even that also be there, since these three will be treated as a foreign keys because it is connected with the team and along with that many-to-many cardinality. So what best we can do at this end is even we can neglect, later we can record, that also possible. Since it is only two, always only the two teams is going to be contested in a match. That's why I have recorded here, and only one will win. So to make things to be very simple, right, that relational mapping, so that I have recorded here, that's it for time being. Then after that, it avoids that re-watching that the whole scenario. Then after this one, guys, stadium. And each match is going to be played in any one of the stadium. We are having a bunch of stadiums. Then all such stadium details we have recorded in the stadium entity type. That's why we have recorded it in. That means for that we have created one stadium entity type. And each stadium is identified based on stadium ID, right? And having a name and present in some address, right? And where address having a many simple components. We have shown it as a composite attribute because it was given in a scenario, right? So it's all about the story behind this year diagram. Now guys, we'll apply these 7 steps on this year diagram and we'll try to convert it into its equivalent relational model. We'll start. Guys, what is the first step is? The first step of year to relational mapping suggests us go with identifying all regular entity types, right? Do we have any regular entity types here? Yes, we are having regular entity types like team, player, match and stadium, right? What's the first step? As per our algorithm of year to relational mapping, for all regular entity types, go with creating new relation, right? Let me go with creating a new relation, guys. In the name of what? Team, player, match and stadium, right? This is what? Year to relational model, right? Relational schema you can write. This is a year diagram. Fine. Next, I'll go with creating this team. Fine. What are the attributes I can record it in the team? What they want, guys? Team ID, team name, city, and a coach. These are the 4 attributes that I want to connect, that I want to add into a team relation, right? Because these are the 4 attributes associated with a team entity type. Let me go with adding all the 4. What is that? The team ID. Fine. What next? Team name. What else we are having? We are having city and a coach. Yes, we have recorded. But we are having one key attribute. You know how a team is going to be identified? Team is identified based on team ID. So for that, here we have underlined. And what is the equivalent notation for a key attribute we are having in a relational mapping? Even here also you underline it. It's an indication that it is a key attribute, right? Yes, it's over about team. Let me take up this player now. So player is a regular entity type. So for that, I'll go with creating a new relation, player. And what are the attributes connected, associated with this player? Player ID, then player name and age. Yes, I have recorded. What next? Here the player ID is an attribute which is used to identify each entities of this player entity type, right? So what to do? Here player ID to be considered as a key attribute. Let me underline it. Yes, fine, done. What's the next step? We are having one more entity type. What is that? Match. Let me go with creating one more table, that means a relation for a match entity type. Yes. Let me record the attributes of match entity type now. What are all? Match ID, then schedule date and time, right? Next, we are having, anyway, the 2 teams are contesting. So for that, I'll record it here. Team ID 1, team 1 ID, and team 2 ID. And the last one, what is that? Winning team ID. So here each match is identified based on what? Match ID. So for that, underline it. Yes, done. For the next step, we are having one more last regular entity type. What is that? Stadium, right? So let me go with creating one more relation for stadium. And I'll record all attributes of this stadium entity type. What all, guys? Stadium ID, stadium name, SID, yes, name, fine. What next? Oh, address is a a composite attribute. It consists of 3 simple components. Let me take it, record it as 3 separate attributes, right, as simple attributes in the stadium, right. What all? City, area and pin code. City, area and pin code I have recorded. What next? The stadium is identified, each stadium is identified based on SID, stadium ID. So that let me underline this key attribute, stadium ID, yes, over. And I have missed here one thing, the relationship type between the player and a match, because each match having what? For each match, one of the player will be, the best performer will be identified as, identified for the man of the match award. So for that, let me take up that relationship type. What is that? Match having a man of the match player, right? Man of the player, right? Man of the match player. Match having man of the match player, right? And one match having only one man of the match player. Every match having what? A man of the match player. Fine, fine. But all player may not get what? A man of the match award. This also be true, right? Fine. Next, guys, let me take up one-to-one conditionality, a mapping of, is there any weak entity type? No weak entity type, leave it. Is there any multi-valued attribute here, guys? So, no, we don't have any multi-valued attribute here recorded as of now, right? So, then do we have any weak entity type? No weak entity type, all regular entity types are recorded, no multi-valued attribute. Next step is what? The mapping of, go with mapping of cardinalities like one-to-one. Do we have one-to-one cardinality? Yes, we are having one-to-one cardinality between player and match. Then what to do? That mapping of one-to-one cardinality can be done with the help of what? Foreign key approach. So what we can do? Always we have to identify where we are having a total participation, that means maximum participation to that entity type, that means to that relation, because for this entity type we will create a, we have created a relation, right? So to that entity type or to that relation, you make use of its opposite, that means it's another connected participating entity type key attribute here. Which one? The player ID as a foreign key. Then what happens? We'll see it. Player ID, right? Player and a match between this. So for that, here we are having a total participation, so that I took this key attribute and I'll make it as a foreign key in the match, right? So that's it here. And this player ID will be treated as what? A man of the match player ID, right? This one. So man of match player ID. I'll rename it. So for that, I'll name it like this, man of the match player ID. You can give any name, no issues. So for that, easily I can identify what exactly this player ID indicating here, right? So what's the role played by that player ID here? Why we have recorded, that all we come to know from that. So for that, better always go with a right naming convention, especially the table names, that means the relation names, and as well as for the attributes of the relation. So then here this is a foreign key. So for that, what I'll do is I'll represent it with the help of this arrow mark, right? With this, right? So this is referring to this one, because look at this one. When I write this man of the match player ID here, then what happens? Why it is will be treated as a wrong notation, right? Or we can say what problem this solution suffers, right? So that we can come to know. Suppose when I write man of the match player ID here, then player ID 1, some player name A, some 20, I'll record. Then man of the match player ID, sorry, match ID when I record here, then what happens? I'll say, suppose if the player gets only one time that man of the match, then I'll record it once. Suppose only if 10 matches were played in an IPL, then all 10 matches having a man of the match award, right? So only for 10 players I'll assign a value, right? Suppose if a same player, possibility that a player can get more than one time that man of the match award. Since that player ID I cannot repeat, so that I cannot show this player got that thrice that man of the match award, that we cannot show it here, right? So this is what our problem we are going to face, right, with this. Next, let me go with this is over. I'll move on to this one-to-many here. So how to map? So one to many and many to one and one to one. For all the three, don't go with creating a new relation. Go with what? Foreign key approach. What I'll do, guys? So I'll consider that maximum cardinality end, right? So maximum n and with maximum participation end here player, and its opposite end key attribute I'll make it as what? A foreign key. What exactly I think I want to show? A team contains a player and a player always belongs to only one team. So for that, once if I consider this team ID as a foreign key in the player, because this is a total participation, maximum contestants, right? Almost all entities are participating here. So for that, I'll pick this team ID and I'll make it as a foreign key in the player table, player relation. I'll take up team ID here, this one, and I'll make it as a foreign key with the help of this. Yes, done. Look at this one, player ID 1, he belongs to one team, because always a player belongs to what? Only one team, right? Then 1, some team ID, some 100, 2, 101, 300 I can repeat again, because since this team ID is a foreign key, I can repeat as many times as I want, right? Possible. Next, we are having a one to many here between stadium and a match. Here what is that? Stadium used for match, right? Stadium used for match, stadium used for match, because stadium ID, stadium name, we are having all stadium details here. So here also again, since we are having a one to many cardinality, what to do, guys? Don't go with creating a new relation. Instead of that, what? Go with foreign key approach. What it says? Where we are having a maximum cardinality and as well as the participation, to that end, its opposite end key, entity type key attribute, you make it as a foreign key here. That means SID of stadium, you take it in the match relation, right? Let me record here. SID, and this is a foreign key, right? Points to this one. So since I can repeat SID many times, it's an indication that a stadium can be used for playing many matches. That's it. And always a match will be played in only one stadium. So for that, because one side in one stadium and another side in another stadium, no, that will not happen. So for that, what? Match ID I cannot repeat. So definitely my problem is solved here, right? Fine. What's the left out thing, guys? Many to many. Suppose this you can do. What is that? Suppose when I say, since this team 1 and team ID, team 2 are all foreign keys and winning team ID is also foreign keys. So for that, either you should not record these three, and later with many to many, that we can solve. This also possible. It's a second way. Suppose, because foreign keys always should not be represented, should not be recorded in an ER diagram. So for that. So you can take out this one, but go with go and again revisit. That means reread the whole scenario, right? The requirement scenario, then pick up the things. Always a match played between two teams. Since this many to many cardinality always says us, suggests us to go with what? Creating a new relation. With that also we can able to solve. That means go with creating a new relation in the name of play and record this match ID. Because in the newly created relation, what we'll do? We'll take the key attributes of two participating entity types. What all? Match ID and team ID. Match ID and team ID. And when you record this as win team ID, because any one team at the end will win, So win team ID. This I can record, because between those two teams, any one team is going to win, that we can record. Suppose when I record it here like this, then what happens, So match 1, team 100 is participating, then match 1, 101, these two teams are participating. But it talks about a single team, So once if it is about, single match, at this point of time I'll record either team 1, team 100 is 1, and then again I want to repeat twice, that also becomes costly. That means same value will be repeated more than once for each match. So what, then do you think that is it a right design? Is it become a very best design? Can we fine tune it? Yes, though it is a many to many cardinality, instead of recording like this, because it makes us to record this 100 twice, that winning team name ID to be recorded more than once. To avoid it, guys, what best we can do is, anyway we know that a match is always played between two teams only, and between two teams any one team is going to win. Right? So for that, instead of going with creating a new relation, what best we can do is, we'll go with adding the two attributes like team1, a match played between team1 and team2. So to either I can record team ID, that becomes what ambiguous thing. So for that we cannot write two attributes in a same table with a common name, that a similar name, that will not, it will not be permitted by SQL, right? So for that, so record it in two different names, team1 ID and team2 ID. So for that it is even easy for us to identify. Then both of them are as what? Make it as foreign keys. Yes, done. And who will win, between these two, that also is what? Present in this team table. So for that it is also again a what? A foreign key. Now look at this one, guys. A winning team name is, we are going to write only once for each match. So for that we avoided that rewriting of a winning team ID. So for that the query writing also becomes what? Very simple, guys, right? Otherwise what happens is we have to, let's say for example, when you want to write, it's all about one more thing we come to know here at this point of time, that even the design also plays a major role, especially a query optimization, guys. What is that, Suppose in the earlier design, when I say what we did, play, there we recorded match ID and team ID, then win team ID. When I say match 1 played in between which all the two teams, when I want to get the data, then every time, let's say if I am having 100 tuples, suppose definitely that comparison is going to happen with each and every tuple, right? And it goes for one comparison, then again one row we got, but that contains only a match ID and only one team which are participating, that data. But we want one more team, which is participating in the match 1. To get it again, I want to revisit one more tuple. That means the tuple comparison is going to be it is huge when compared to this one. That means it is double. The number of comparison is going to happen, it is double in case of this design. Suppose when we go with this design, guys, when I say teams participating and winning team IDs, I want that data of some particular match. That can be done only with what? Only one comparison, guys. But look at this one. The number of comparison becomes what? More, right? Because I want to retrieve two teams, this is what a problem. Or you can go with match ID, then team ID with team1 ID, team2 ID, then followed by winning team ID. That design I can make. This is also possible since I know that. But instead of doing here, what best we can do is I can record it here only, right? So that it avoids, again, if I want to get the stadium ID and other data, I need to go with what? Joining. So that even joining, writing such joining condition, that also becomes what? Requires one more comparison. That all we can avoid it here, right? So one join we can avoid with this design, and one comparison that we can avoid, right? So whether this becomes a right design even with respect to query writing also, right? Query optimization point of view also, this becomes a good design, right? So for that there's no problem in writing. For our understanding purpose, what is a team1 ID? Because that gave birth to one beautiful design, So for that, team2 ID, and we are very much damn sure that a match is played between the two teams for that record, right? So for that, this helps us in coming up with this kind of a design, right? So is there anything left out? No, almost all cardinalities we mapped, and we don't have any NRI relationship type, right? So almost we covered everything, right? So all ER diagrammatic notations which are present in this scenario, in this ER diagram, that all we have converted into this relational model, right? Now simply going with what? Creating of these tables with the help of in the SQL with the create table statement, right? With suitable primary key and foreign key notations, right? So that itself solves our problem, right? Thank you, guys. Thanks for your patience listening. Now we will try to discuss about the fourth exercise of our lab set, that is our year to relational mapping part for the fourth exercise we will do now. So guys, that fourth exercise we constructed this kind of a year diagram in our previous sessions, right. So now before converting this into a year into a relational mapping, right, that means to a relational schema, we'll try to recall the story behind this year diagram, guys. The story behind this year diagram is it's all about tourist places, right, such kind of a thing, and in which date the tourist visited which place, right. So those things we want to record. We are having plenty of tourist places and each place is identified based on a tourist place ID, right. So I have missed this one, place ID is a key attribute and tourist ID is a key attribute here, right. And each tourist place is identified based on place ID and having a name, and each place belongs to some state and belongs to some country, having some history, then it's having some kilometers from its capital city of that state, right. So that also we want to record, so that we have associated all these attributes to this tourist place. Then after that there are so many tourists, right. So plenty of tourists are available, that we have identified tourist kind of an entity type. Then each tourist is identified based on uniquely with the help of tourist ID, TID, then having a tourist name and having some age, then belongs to some country, and having a multiple email IDs. A tourist might have a multiple email IDs, so that we have recorded as a multi-valued attribute. And a tourist place can be visited by many tourists, and a tourist can visit many tourist places, right. So and one more, in which date the tourist has visited, even that also we want to record. Visited date, sorry. This is what one more attribute. So for that a tourist visited which place and which date, so those things we want to record. And a place can be visited multiple times by same tourist, that also be there, and which date he has visited, that also we want to record actually. It's all about this, what the story behind this year diagram. We'll try to convert this we'll try to map this into a relational schema, guys. So to do that, again already we have discussed the 7-step algorithm of year to relational mapping, where it involves that mapping of regular entity types, mapping of weak entity types, mapping of one-to-one, one-to-many and many-to-many cardinality, and mapping of NRI relationship type, and as well as at the end mapping of a multi-valued attribute. We'll try to identify all regular entity types, that means a strong entity type in our year diagram. The two strong entity types which are present, only two entity types are present, and both of them are of what type? Are of a strong entity type, regular entity type. So for these two entity types, regular entity type, tourist place and tourist, we'll go with creating a new relation, guys. In the name of what? One is tourist place, right, tourist place. For that I'll go with creating one relation. Then what are the attributes of this tourist place case? The attributes are what? Tourist place ID, place name, right, those things. Let me go with according T place ID, tourist place name. Next what? State, history, and country. Then after that what? We are having a number of kilometers from capital, right? Kilometers from capital. What next? Then after that history be recorded. No, we have not recorded. Yes, we have recorded history. Almost everything, all 7 attributes. 3 plus 3, 6. What's the left out thing? Yes, 6 only. Yes, all 6 attributes we have recorded here, right? So what's the next one? So next one is a tourist. Let me go with creating a new relation, because since it is a stronger regular entity type, right? So tourist. Yes, they have created. So what are the attributes of this tourist case? Attributes are tourist ID, tourist name, age, country. All are simple attributes. Let me go with that. Tourist ID, tourist name, next age, then what? Country. Then one more thing we missed. What is that? In the tourist ID is a key attribute. Underline it, fine. In the tourist place ID is a key attribute. We'll go with underline both attribute, right, as a key attribute notation, fine. Then after that, guys, we are having an email ID as an attribute, but it's a what kind of attribute? It's a multi-valued attribute. Then how to represent a multi-valued attribute, guys? A multi-valued attribute always is going to be represented with the help of what? Creating a new relation, right? So because directly writing a email ID as an attribute here, where it doesn't permit us to write a multiple email IDs to record, right, in the tourist relation, right, that doesn't permit. So since this tourist ID we cannot repeat, right, since it's a primary key. So for that, what to do? Let's say tourist email kind of a table, that means a relation we'll try to create. Tourist email. Then let me go with recording the attribute like email ID, yes. So then this email ID belongs to whom? It belongs to some tourist ID. So for that, you record this tourist ID as foreign key in the tourist email, right? That's it. Then make it as what? A foreign key here with this notation. So for that, it points to this one. It takes only the values which are present in the tourist, right? Referential integrity it holds, right? Next. So I can repeat as many times the tourist ID I want. So for that, if a person having one email ID, that I can record. If he is having a 10, that also we can record, right? If a person doesn't have any email ID, then also no issues, because such tourist IDs will not record here. Suppose if email ID, if it is present here, then it suffers from too many null values, right? So this is what a problem we are facing, right? And we don't know for an entity what is a maximum or a minimum that email IDs they are going to enter, right? So for that. Next, we are having no one-to-one, no one-to-many, then no weak entity type, right? We are having only no NRI relationship type. We are having only many-to-many cardinality. How to map it? To map many-to-many cardinality, our year-to relational mapping algorithm suggests us to go with creating a new relation, right? Let me go with creating a new relation, guys, because even if I go with a foreign key approach, that doesn't help us in solving the whole problem. What exactly this many-to-many coordinate is conveying? A tourist place can be visited by many tourists on so and so date, right? And a tourist can visit many places, right? Either the same or different places as many times as you want on some so and so dates. That I want to record. Suppose if I record this tourist ID as a foreign key here, then what happens? I cannot repeat a place ID. So it's an indication that if a place was visited by any one tourist place, then we cannot make that place to be visited by many other tourists, right? So where it doesn't permit us to re-record, or we can say to repeat this place ID. Suppose if I take this place ID here, then tourist, once if he visits one place, if he or she visits one place, that I cannot repeat, so that a tourist, it doesn't permit a tourist to visit many places. That means we cannot record such kind of a details here. So for that, this foreign key approach, either placing this place ID as a foreign key here or tourist ID as a foreign key here, that doesn't solve our problem. To solve this, since it's a many-to-many, it strongly says or suggests as per our relational mapping algorithm to go with creating a new relation. What name to give, guys? Visit. Let me call my name visited by or visit. Some name you can give. Next, record the attributes. What all, guys? Pick the attributes from the two participating entity types. Key attributes from the two participating entity types. What all? The two entity types are associated with this relationship type participating. What is that? Place ID and tourist ID. Let me record T place ID, tourist place ID, and next one is tourist ID. And make this as what, guys? A foreign key. So for that, let me make this place ID to point to this tourist place table, then tourist ID to point this tourist ID, right, this one. What next step? What next to do, guys? There's one more attribute which is associated. What is that? Visited date. So from this we come to know that I can repeat, since both of them are foreign keys, I can repeat both of them as many times as I want. Place ID 1, tourist ID 100, 1, 101, like this I can repeat. Next 100, 1 with 100, 2, 103 that I can write. So for that a tourist can visit many places. Both I can show it here, right? And same thing also I can repeat with different date. So visited date is an attribute which is connected with this visited relationship type. Since it's a many to many, we have created new relations. So for that, attach even this also to this one, because I want to show this place visited by which tourist on what date, right? So that also I want to record. Visited date. That's it. Is there any left out thing, guys? No. Almost we have considered everything, right? For two entity types, two relation. Multi-valued, new relation with making one of the attribute of associated entity type key attribute as foreign key. Then since it is a many to many, we created a new relation, and the additional attribute which is connected to this many to many cardinality relationship type, to that we also added to that newly created relation, right? And we identified the right key attributes and foreign keys. That's it, guys. This solves completely our problem. This is what it's this ER diagram equivalent relational model, guys, right? So this is an ER diagram. And this one is its equivalent relational schema, conceptual schema we can call, a relational model or schema. That's it. Thank you, guys. Thanks for your patience watching.